Welcome to the lesson on circles and sectors. So our essential question and objectives: what is a sector of a circle and how do we calculate the area of a sector of a circle? Okay, so much like an arc, it's a certain proportion of of the circle. It's a part of the circle. A sector is the area that's enclosed by the arc and two radii. So this kind of like pizza slice looking shape here. That area inside is called a sector. So much like the arc is part of the entire circumference of a circle, the sector is part of the entire area of a circle. So let's remember that the area of a circle is A equals pi r squared. That's the formula for the area of a circle. And so we can find the areas of certain sectors. Now, there's special sectors called like a semicircle. That's half of the area of a circle. So that's going to be 1/2 pi r squared. So you're taking the area, which is pi r squared, multiplying it by 1/2, so the area of a semicircle would be 1/2 pi r squared. For a quarter circle, it's a quarter of the circle, so it's a quarter of the area. So you take the area, pi r squared, and you multiply it by 1/4. All right, and so, for example, a semicircle would be, that central angle would be 180 degrees. So 180 degrees out of 360 degrees would be 1/2. So it's going to be half the circle, or half the area. For a quarter circle, the central angle is 90 degrees. 90 out of 360 is 1/4. So it's a quarter of the circle. So a quarter of the area. Now, we can apply that same kind of thinking to any sector. As long as we know the measure of the central angle, which will be n in this formula right here, as long as we know the measure of that central angle, we can divide the measure of the central angle by 360 degrees. That'll give us the percentage of the circle that the sector takes up. If we multiply that percentage by the total area, it'll give us the area of that part of the circle, that sector. So it's the fractional part of the area. We can also think of it as where, if we know the arc length, so we know that it's also that percentage of the central angle to the total degrees or the ratio of the central angle to the total degrees of a circle, so n to 360. That's also, we learned, is the same as the arc length, or the length of the arc compared to the central, to the entire circumference as well. So we can also think of, if we know the arc length, we can take the arc length divided by our circumference, which is 2 pi r, and we can multiply that by the total area, because the arc length divided by 2 pi r is going to give us the same percentage or ratio as the central angle divided by 360. So again, to recap, notice that when finding the area of a sector, you are actually finding a fractional part of the area of the entire circle. The fraction is determined by the ratio of the central angle of the sector to the entire central angle, which is 360 degrees, or by the ratio of the arc length to the entire circumference. The second formula can be algebraically reduced, but it is easier to remember that you are dealing with fractional parts. Here's an example. Find the area of a sector with a central angle of 60 degrees and a radius of 10. Express answer to the nearest tenth. So our central angle is 60 degrees. So we're going to take the ratio of the central angle to the entire amount of degrees in a circle, which is 360 degrees. And we're going to multiply that by the area, which is pi r squared. And now remember, our radius is 10. So if I multiply all that together, I get this big long decimal here, 52.35. And if I round that to the nearest tenth, 5, that means I'm going to round up to 4. So my area equals 52.4. Another example, find the area of a sector with an arc length of 40 centimeters. This time we're going to be using arc length and a radius of 12. So I know that my radius is 12. So, and I know that the arc length is 40. So I can find the ratio of the arc length to the entire circumference. So I'm going to substitute 40 in, that's part of the circumference. I'm going to substitute 12 in for r. So 2 pi times 12, that's the formula for circumference. And I get 24, I would get 24 pi. And so if I multiply all that out, and I'm multiplying by the area to find the percentage of the area that the sector takes up. And if I multiply that all together, I get 240 square centimeters. Don't forget that if a problem includes units, you should include the units in your answer. Over here there were no units included because we didn't know what the circle was measured in. It didn't tell us with the radius. It just said 10. So our answer for our area would just be units squared, or you could just leave 52.4 as your answer. However, if they do include length units, then you should include them in your answer. Here we have what's called a segment of the circle. The segment of the circle is the region bounded by a chord, or the line between the 2 points on the circle here that you see for the segment. Here's one point, here's the other. If we draw a straight line, it's that little sliver at the end of the sector that's called a segment of a circle. And if we wanted to find the segment of a circle, we would take the sector minus this little triangle here made by the radius, the degree, the degrees of the central angle, this triangle here. We would subtract that from the area of the sector, and that would give us what's left over is the area of the segment. So for example, if we had to find the area of a segment of a circle with a central angle of 120 degrees and a radius of 8, we'd start by finding the area of the sector. We'd do that 120 divided by 360 times the area, which is pi times 8 squared. 120 divided by 360 is actually 1/3, so we're going to find 1/3 of the area of the circle. And that's going to give us 64/3 pi, which is roughly 67 square units. Now, remember, if it asks you to round your answer to the nearest whatever, if you have long decimals in your problems but it's not the final answer, it's important to include those long decimals, because as you do more calculations, they're important to stay accurate so that you find the accurate final answer. Now, once you do get to the final answer, you can simplify. Definitely express it in the way they ask you to. However, don't simplify or round your answer until the very end. So now we got to find the area of the triangle. Dropping the altitude forms a 30, 60, 90 degree triangle. So the altitude is 4, and the other leg which is 4 square root 3. So if we do the area of a triangle, 1/2 base times the height. So the height is our altitude, the base is 6.92, and so on, times 2, times 1/2, simplify all of that, and you get 27.712,81292, and then you subtract the 67 and change, you take away 27 and change from that, and you get 39 and change. If we're rounding to the nearest integer or whole number, we get 39 square units. That's all I have for you for this lesson. I hope you learned a lot. I hope you know what a circle, or what a sector of a circle is, and how you can calculate the sector.